This video, we are going to be tackling the LeetCode question, single number. This is an easy question to understand. And if you just take a look at this array, take a look at each value and think to yourself, what is likely the single number, aka the lonely number? If you guessed 2, you would be correct, and that's because all of the other values in the array, all the other numbers have 2 values. 2 is the only number with just 1 value. This is the lonely number. Simple enough. LeetCode has even gone on to state in the constraints that all of the arrays given to you are going to come in this format, so you don't have to worry about these other numbers having maybe more than 2 numbers. It's just going to be 2 to 1, just like this. But you may be thinking to yourself, this sounds a little bit too good to be true. This sounds too easy. And if you're thinking that, you would be correct, because in the LeetCode description, they state that it has to have a linear time complexity and a constant space complexity. We could get away with just using a hash map, but the bad thing is that they ask for a constant space complexity, and hash maps actually have a linear space complexity, so we cannot actually use a hash map. And what do we have to use? We actually have to use something called bit manipulation. So if you are a C# developer, this probably is a little bit foreign to you, but let me just go through and explain it very quickly. Bit manipulation works a little bit like this. All of the photos, all of the videos in your computer are comprised of zeros and ones. It's digital. But how are these zeros and ones actually created? Well, your computer's flipping electricity on and off at incredible speeds. And when the electricity is off, it's represented as a 0. And when the electricity is on, it's represented as a 1. And bit manipulation will actually allow us to manipulate these bits on a comparison by comparison basis. What exactly do I mean by that? Well, there's many ways that you can use bit manipulation. We have things like an AND, we have an OR, we have a XOR. XOR is what we're going to be using in the LeetCode question, but we need to work our way up. And we're going to start with the most simple type of bit manipulation. Now, remember what I said. These numbers are being manipulated on a comparison by comparison basis, and all that you're going to be doing is comparing 2 sets of numbers through each bit manipulation. So we're going to compare these numbers, we're going to compare these numbers, we're going to compare these numbers, and this comparison of each number right here is going to produce just 1 set of numbers. And with an AND, it basically means both numbers have to be the same. What exactly does that mean? Well, 0 and 0 are the same, so it's going to be a 0. 1 and 1 are the same, it's going to be a 1. 0 and 1 are not the same, so it's going to be a 0. Pretty simple. So next up, we have the OR. And the OR is going to be very similar to the AND, but in one key difference. There's one key difference, and that is both numbers can be the same, so it's very similar to the AND in that aspect, but also if just one of the other numbers is another number besides 0, it also is going to produce the same number as well too. So we have a 0 and a 0, it's going to be 0. 1 and a 1 is going to produce a 1. And we have a 0 and a 1, so it's also going to produce a 1. And the next one is going to be a XOR. A XOR is very similar to the OR previous, but it's a little bit more constricted. It's a little bit more locked down. And all a XOR means is this, and this is the whole entire, this is what we're building up to and what we're going to be using. We're going to be using XOR in the LeetCode question. Only one of the numbers can be different. So if one of the numbers is different, a 0 and a 0 obviously is going to produce a 0. But if one of the other numbers is anything besides a 0, it's going to produce that number. And also, if both numbers are the same, it is going to produce a 0 as well too. So if both numbers are the same, no go. And that's the whole entire reason that we learned all of that. And a XOR is what we're going to be using in the upcoming explanation of the LeetCode question. So let's go ahead and explain the LeetCode question. Basically, what we're going to do is we're going to iterate through every single number and we're going to add it to a variable. So we're going to go ahead, we're going to start our for loop. We're going to start with the first number. We're going to add our first number to a variable, so it's going to be 2. And then we're going to use a XOR operator to compare it. So we're going to compare the 2 and the 2. The 2 and the 2 are the same. And in Zora world, if both numbers are the same, it's going to equal a 0. So it's going to return nothing. And this is what's going to allow us to return everything except for the lonely number, because it's going to cancel out duplicate numbers. So by the time that we get to a 1, this is actually going to be a 0, and we're going to be adding a 0 to the 1, which is only going to leave us with a 1, which is indeed the number that is going to be the lonely number or the single number. So let's go ahead, let's hop inside VS Code and let's code it up. So we are inside of Visual Studio Code right now, and the first thing that I'm going to do is I'm going to create a new class, and I'm going to call this solution. Within this solution, we are going to just go ahead and put down the boilerplate from LeetCode. If you want the link for the LeetCode, I'll leave it down in the description below. So I'm going to go into here. The actual name of the method is single number. It's going to be an integer array of nums. Go ahead, put down some curly braces. So because we need to find this single number, we need to find this lonely unique number, what we need to do is we need to actually create state for it. And we're going to create the state in the form of a variable, this variable a. This is where we're going to store the number that we find. Next thing that we're going to do is we're going to declare a for each. And because this is going to be such a simple for loop where we're going to iterate from the very beginning to the very end, we don't even need to use a traditional for loop with incrementers and stuff. So here's where we're going to use the XOR, but you may not be familiar with what the syntax actually is, so I'm going to explain it for you. This is actually very similar to this syntax right here. This syntax right here, the addition with the equal sign, is going to add every single I to the variable a. So in a sense, it would add every single number, but we don't want that. We only want to add the unique numbers. We only want to add the XOR. And remember from our whiteboard example, XOR is only going to check the numbers that are not the same. So if we add the same number, it's not going to compute it with a XOR. And that is exactly what we want. We only want to compute the unique numbers. And that's exactly what we're going to do. Then we're going to return it. So let's go ahead, copy this, and go ahead, bring over LeetCode. I'm going to get LeetCode over here. Going to go ahead, bring this over right here. Let's take our code that we got from VS Code, bring it back over here, make it look a little bit better. Shift tab this over, and let's go ahead and run it, see what we get. All of our test cases are accepted. Let's go ahead and hit the submit button, check our time complexity. We have a time complexity of linear, which is a pass, but we also need to make sure our memory is sublinear and constant. We have a constant space complexity. Congratulations, guys. We passed the LeetCode question. Hope that you guys enjoyed this. If you did, make sure to smash that like button, smash that subscribe button, and as always, thank you for watching.